Okay, so this last example, we're going to find the values of w then x, then round the lengths to the nearest tenth, and angle measures to the nearest degree. So let's take a look here at what we've got. Again, we have two triangles. I say again, in the last homework we had some examples where we had two triangles. And let's see, what else? We've got arrows. Arrows mean parallel lines. They make us think about Z's, F's, staples, and crab claws. So I hope that you're noticing you have some alternate interior angles here, which would mean we have congruent 90-degree angles there. And we know that that's important because we know that this strategy only works in right triangles. So we can now use sine, cosine, and tan on the green triangle as well. So let's see, let's start with the yellow triangle, I think, since I have more information to work with on that one. This is opposite and this is hypotenuse, so that would mean what? Sine would be W over 12, and so sine 30 in my calculator is 0.5. Equals W over 12, and so cross multiply 0.5 times 12 would be 6, so W is 6. Oh, and look, we could have figured that out without using sine, because isn't this a 30, 60, 90? And so short leg would have been half of the hypotenuse. So that would have been a faster method that would have also found us the same answer. All right, now we're ready for the green triangle. Let's see, on this one, this is hypotenuse and adjacent, since that's next to x, so this one would be cosine of x equals W over 8. And so, oh, but wait, we know W is 6, so we can plug that in. So cosine x, so in this case, since we don't know the angle, this is one of those where we will cos inverse. So second in the cosine button on our calculator, and I'm getting that to come out to be 41.4, so to the nearest degree, approximately 41 degrees. Okay, part B. Again, two triangles. This time, I'm noticing that I have that 90-degree angles, which means it'll be 90 degrees on the other side. I'm also seeing some congruent rings, which mean those two angles will be congruent, which will come in handy here in a minute. So perhaps you notice that this is a triple. It's a 3, 4, 5. Not that we need that 4 side, but still good for you to be looking for those triples. Okay, so we have opposite and hypotenuse. So that would be a sine problem. So sine W equals opposite 3 over hypotenuse 5. So since our angle is what we're looking for, we're going to sine inverse. So W comes out to be approximately 37 degrees. Now, you know what? I'm going to write this down because this is going to be important. 36.8698 ... which is approximately 37 degrees. All right, so when I go to solve for x, I'm going to use this second triangle here. I know now because these angles are congruent, this is also 37 degrees, in which case this is my hypotenuse. Oh, but this isn't opposite anymore. On the green triangle, that is adjacent. So we have, what, cosine of 37 degrees equals adjacent over hypotenuse. Now, here is the thing. I set 37 degrees, but we never round intermediate values. We never round a number that I'm going to turn around and use again to make another calculation. So technically, guys, I need to be using cosine of 36.8698 ... because I don't want to round that fully. So this is a great time to use that copy and paste feature on our calculator. Okay, so on the calculator, we already did the sine inverse of 3/5 and got the 36.86. So now we're going to do cosine. Just scroll up on top of that number and press enter. And if you do it with the copy and paste feature, it gives you 0.8 exactly. So this whole thing is 0.8 that equals 3 over x. So when we cross multiply, 0.8x equals 3. We want to get x by itself, so I'm going to divide by that 0.8 to get x by itself. And so 3 divided by 0.8 gives us approximately 3.75. So to the nearest tenth, approximately 3.8. All right, we've got a couple more here. This is just to bring your awareness that these right triangles for the rest of the semester will not be isolated. They will be inside of another shape. So don't let that scare you. This is still just this right triangle here. This is still just this right triangle here. The hexagon and the trapezoid actually have nothing to do with this problem. I just don't want it to scare you when the right triangle that you need to solve is inside of another shape. So on part C, there's actually a cheater's trick. This is opposite and hypotenuse side, so you could do that. Did anybody notice, though, that this is double this number? Where have we seen that pattern before? I hope you're thinking about 30, 60, 90, that across from 30 is some number n, and the hypotenuse is 2n. Okay, so if that didn't occur to you, that x would automatically have to be 30 because of that pattern, and that pattern only works with 30, 60, 90, then of course you can sine x equals 5 over 10, and then x would equal sine inverse of 5 over 10, which would be 30 degrees exactly in your calculator. Okay, so either strategy works. Let's look at the U-try. Okay, so this is opposite and hypotenuse. Again, so I'll give you a second to U-try, and I'll see you after you've solved it. Okay, so since we didn't know the angle, that's when we sine inverse in our calculator. So sine inverse 2 over 40 comes out to 2.865 and some more decimals. So since we're going to the nearest degree, that would be 3 degrees. Okay, so your homework will be in Math Excel. I won't see you next class on Wednesday. So this will actually be due on Friday so that you don't have homework on family night. Okay? All right, see you soon. Bye.